Welcome to Crack Defense. In this video, we are going to learn about Newton's laws of motion. Let's quickly start. So, there are three total laws. We call it as Newton's first law, Newton's second law, and Newton's third law. Let's quickly start with Newton's first law. A body at rest will remain at rest, and a body in motion will continue to remain in motion until and unless an external force is applied to it. So basically, it depends on concept of inertia. Now, what is concept of inertia? A body resists change in its state of rest or of uniform motion. And we have three types of inertia. First, inertia of rest. That means a body in rest will resist to move when applied force. Second, inertia of motion. A body which is already in motion, a uniform motion, will resist to stop when applied force. And third, inertia of direction. A body which is moving in a particular direction will resist to change its direction when applied force. Now let's move on to Newton's second law. It says force applied to a body is directly proportional to the rate of change of momentum, which is produced by the body. Now what it means? You have a body on which we have applied a force, so its rate of change of momentum, and momentum here we know that it is mass into velocity. So at the very initial stage, if mass is m0 and v0 is the velocity, and at a later stage when the force is applied, we have m1 as a mass and v1 as a velocity. So rate of change of momentum. As per formula, it becomes m1 v1 minus m0 v0, and we have t1 minus t2. That means time at this point and time at this point. Now, if mass is constant, so we'll have force equal to m, taking it common, v1 minus v0 and t1 minus t0, which eventually is making it mass into this one becomes acceleration. So the formula is force equal to mass into acceleration, which states the Newton's second law. Now let's move on to Newton's third law. It says every action has an equal and opposite reaction. That means when two bodies act upon one another, their total momentum remains constant, provided there no external force has been applied. For example, when we jump, when a person is there and he jumps up. So that action, when we do, we apply a force on the ground. And similarly, equal and opposite force is applied on our legs, which eventually propels us into the air. Such kind of lot of examples you'll find around you. Thank you.